This exam is from May-June 2022, paper 22. You have 1 hour and 15 minutes to complete this exam, and the total mark for this paper is 60. This is the information provided for your exam. You have a list of data and a list of formulas. This is a larger screenshot of the data list. For AS level, you need just the acceleration of free fall, speed of light, elementary charge, AMU, the mass of the proton, and the mass of the electron. The list that is crossed with this red line is for the A level. And here are the formulas provided. 2 formulas for motion, hydrostatic pressure, upthrust force, or Archimedes principle, Doppler effect, electric current in a wire, resistors in series, resistors in parallel. Question 1a. In the following list, underline all units that are SI base units. To review all the units, I have this list for you. Physical quantity, unit name and symbol. Length, meter, m, mass, kilograms, time, seconds, electric current, ampere, temperature, Kelvin, amount of substance, mole, luminous intensity, candela. So to answer this question, we have ampere and kilogram only as SI base units. Question 1b. The figure 1.1 shows a horizontal beam clamped at one end with a block attached to the other end. The block is made to oscillate vertically. The Young modulus E of the material of the beam is given by this formula. M is the mass, T is the period, K is the constant. A student determines the values and percentage uncertainties of K, M, and T, lists the percentage uncertainty here in this table. The question asks to calculate the percentage uncertainty in the value of E. Before you do anything, you have to look at the formula and find the variables. So if you are going to find the percentage uncertainty of E, you don't have to rearrange this formula, it's ready to go. But the variables that we need to look here is K, we have, M, we have, and T, we have, but T is a square. So there is some adjustments you have to make in order to get this right. I will show you. So here is how you calculate the percentage uncertainty. This is the format that you need to write. So this delta here is not the change of. This delta is just a notation for uncertainty. So this is percentage uncertainty. So make sure that you write the percentage. And then you have the percentage uncertainty for K, M, and T. So notice here that T you have to multiply by 2 because T is a square. If it was 3, and then you'll be 3 times. If it was 5, you'll be 5 times. Got the idea? Then the rest is just substitution. For K is 2.1, right from the table, 0.6, and 2 times 1.5, and the final answer is 5.7%. Now the next question is asking to determine the value of E with its absolute uncertainty. With an appropriate number of significant figures, they say that because if you look here, the answer is give you times 10 to the 9 Pascal. So you have to adjust for that with the exponent, but I'll explain later. So now let's take a look. What is the absolute uncertainty? When they say that absolute uncertainty, real uncertainty, accurate uncertainty, I have some names like that, but the most common is absolute uncertainty. Means that the value has a unit. Now we have everything is percentage. In percentage we don't have a unit. So this is what you need to do. The next step is convert the percentage to regular number. So you get 5.7 divided by 100. Now you see the percentage here disappear. Great. The next step, you are going to multiply this by E. So it's just kind of cross multiplication. So the absolute uncertainty of E is 5.7 divided by 100 times the value of E. The value of E was given in the question. So this is the value of E given. And then after we do all this multiplication, that's what we get in the calculator. 10 to the 10. How we are going to do to be 10 to the 9? It's very simple. You're going to move the decimal. So if you move one decimal, and then this becomes 9. So now we are ready to go. 5.7. And this is the right way to kind of, this is two significant figures. To be sure, just do 0.5. 0.5 with one decimal place here. So that's the final answer. All right, question 2 is a piece of work. You need to pay attention on that. A sphere is attached by a metal wire. This is the metal wire. This is the sphere to the horizontal surface at the bottom of a river. Horizontal surface, the bottom of the river. So we have water around this sphere. The sphere is fully submerged and in equilibrium right here at 68 degrees at this moment. The weight of the sphere is 32 newtons. The upthrust acting on the sphere is 280 newton, and the density of the water is 1 times 10 to the 3 kilograms per cubic meter. Assume that the force on the sphere due to the water flow is in a horizontal direction, acting this way. By considering the components of force in the vertical direction, determine the tension in the wire. Okay, so let's look all the forces like pretty much a free body diagram. So let me start with the weight of the sphere downwards, and is 32 newtons. And then we have the upthrust force on the sphere. So the name say up, so means up. That's the upthrust force. And then we have this wire right here. So we have a tension this way, and we have a tension. You have the components Tx and the component Ty. Now, let's say if you decide to do the tension, this tension in the opposite direction, could you? Yes, you could do that too. But then the Ty will be inverted. Okay, next step is the system is in equilibrium, so the sum of forces up is equal to the sum of forces down. So Ty plus F up is equal Fg. So Ty is negative 248. Now to calculate the tension, you need to use the components, the vertical component, because here it says, right, the vertical component. So the sine of 68 is equal to Ty over T, because if you could move the Ty here and close this triangle, and then the triangle here, the Ty will be the opposite. So we use sine. And you are going to rearrange this in terms of T, and the value of T is 267 or 270 newtons. And the next question is to find the volume of the sphere. All right, so we have the density of the water, which is mass over volume. The only density that was provided was the water. And we have the upthrust force, which is the density of the liquid, times G times the volume of the water displaced, which is exactly the volume of the object that is submerged, in this case, the sphere. So we can use this formula because the density is of the water, not of the sphere. For this reason, if you are going to calculate the volume using this formula, you're going to calculate the volume of the water. So doing the substitutions here, we have the F up is 280, the density of the liquid is 1 times 10 to the 3, gravity, and the volume displaced, which is the volume of the sphere. Now be careful with this question because usually students think this density is the density of the sphere, and it's not. It's the density of the fluid at which the object is submerged. Now we are going to rearrange this in terms of the volume of the sphere, which is 280 divided by 1 times 10 to the 3 times the acceleration of gravity, and that's the volume of the sphere, 0.03. Now it's asking to find the density of the sphere. So we're going to use the same formula, of course, but the mass here will be the 32 newtons, which is the weight, divided by 9.81, divided by the volume of the sphere that we just calculated, and the density is 108 kilograms per cubic meter. Now things go a little bit wild. So the center of the sphere is initially at a height of 6.2 meters above the horizontal surface. So this is the center of the sphere, and this is the height above the horizontal surface. The speed of the water then increases, so the water that is hitting the sphere increases, right, the speed, causing the sphere to move to a different position. So right here, let's say the sphere is right here. Now that's the center, and there is a height to the ground, to the horizontal surface of the water. This movement of the sphere causes its gravitational potential energy to decrease by 77 joules. So at this position, 6.2 meters above the base of the river, there was a potential energy due its position to the ground. But now the sphere is below, is closer to the ground. So there was a decrease of 77 joules of energy. Calculate the final height of the center of the sphere above the horizontal surface. So we are using the formula for potential energy, which is mass times G times height. The mass is 3.26, which is the weight of the sphere divided by 9.81 is 3.26 times G times the height, 6.2. So that's the potential energy at this position. So the change in potential energy, because the change of position of the sphere, because the water flow is going faster now, is 198.3 minus 77. So at this position, H, the sphere has a potential energy of 121.4. So to calculate this height, we can use the same formula that we used before, but now this height will be the height that we are looking for the value. So rearrange this. So this is 121.4 divided by the weight, and this height is 3.8 meters. Now the next question talk about the extension of the wire increases when the sphere changes position as described in C. The wire obeys Hooke's law and state a symbol equation that gives the relationship between the tension in the wire and the extension, and identify any other symbol that you use. So Hooke's law is force or tension, in this case, time equal to the constant of the wire, of the spring, whatever is stretching, times the extension. So where K is a constant. That's all that you need to do for this question. Before the sphere changed position, the initial potential energy of the wire was 0.65 joules. The change in position of the sphere causes the extension of the wire to double. Calculate the final elastic potential energy of the wire after the sphere has changed position. For this question, I'm going to copy paste here the mark for this section here because I want to use the time to touch base with the other questions. So here is the screenshot from the mark, the key for this test. Question 3. A man is standing on a wall, throws a small ball vertically upwards with a velocity of 5.6 meters per second. The ball leaves his hand, and when it's a height of 3.1 meters above the ground, as shown in the figure 3.1. Assume the resistance is negligible, which means we can use motion equations. Show that the ball reaches the maximum height above the ground of 4.7 meters. So here is a data table, and the maximum height will be the distance here where the man throw the ball to the ground plus this section right here that we don't know. All right, to find this section, we need to calculate this distance right here. So let's consider the ball is thrown upward from the hand of this man to a maximum height. So the initial velocity is 5.6, the final is 0. This height here, or distance, unknown. The acceleration is negative, and the time we also don't know. So we are going to use this equation right here. Vf squared is equal Vi squared plus 2AD. So after doing the substitutions, D is 1.589. So now we are going to add to 3.1. So the maximum height is 4.7. Now the man does not catch the ball as it falls. Calculate the time taken for the ball to fall from its maximum height to the ground. I'm going to do something different. I'm using conservation of energy. So the ball is all the way up, we have potential energy. And when the ball is all the way at the ground, we don't have potential energy anymore. Now we have kinetic energy. So all the potential energy from the maximum height was transferred to the kinetic energy at the bottom. So that way we can equalize the formulas. Potential energy is mgh, and the kinetic energy mv squared over 2. Mass we can cancel, good thing because you don't have the value of the mass. So, and then we can do substitution, and the velocity the ball hit the ground is 9.6 meters per second. The next step is this one. So now we are going to use a motion equation formula with the final velocity 9.6, the initial velocity is 0. because it's from maximum height. Now the ball is falling, right? So the ball is stopped all the way up and then falls back down. So the initial velocity when it's falling down is 0. And now it's accelerating, so it's 9.81 times time. So rearranging all these, now our time is 0.978 seconds. The C section of this question. The ball leaves the man's hand at time t is equals 0, right here, and hits the ground at time t, uppercase T. On this graph, sketch a graph. I said graph twice. So on figure 3.2, sketch a graph to show the variation of the velocity v of the ball from time 0 to time uppercase T. Numerical values of v and t are not required. Assume that v is positive in the upward direction. This is very simple. In order to draw any graph, we need at least 2 points. So 1 point is when the time is 0, when the ball leaves the hand of the man. We know by the question the velocity is 5.6 meters per second. And we calculate the time when, not the time, the velocity when the ball hits the ground, which is 9.6 meters per second. So now that you have time 0 and velocity is 5.6. So let's mark here, right? So consider that each little box is 1, and we have up to 10. So let's say this is 5.6. And at the time t, the velocity is 9.6. So again, this is 10, so it'll be a little bit less than that. So now you have those 2 points on the graph. You can easily draw a line connecting those 2 points. State what is represented by the gradient of the graph. So this is a velocity time graph. The gradient or slope represents the acceleration of the ball. The man now throws a second ball with the same velocity and from the same height as the first ball. The mass of the second ball is greater than that of the first ball. Assume that air resistance is still negligible. For the first and second balls, compare the magnitude of their acceleration. With absence of air resistance, acceleration is the same for both balls. And the speed with which they hit the ground. With the absence of air resistance, both balls hit the ground with the same speed. Question number 4. Let's go. State the principle of conservation of momentum. The sum of the initial momentum is equal to the sum of the final momentum in a closed system, which means that without external forces. Two balls, X and Y, move along a horizontal frictionless surface as shown from above in figure 4.1. So here we have X and Y. They are going to collide and they are going to move together with a final speed of 3.7 meters per second. By considering the components of the momenta along the line AB, so horizontal, calculate the angle theta. Ball X has a mass of 3 kilograms and velocity 4 meters per second in a direction of an angle theta to a line AB. So here, what it says is we have this velocity that is not aligned. So we need to find the component, the horizontal component of this ball X. So this is the horizontal component, and this is the horizontal component for Y. Because say the same story, ball Y has a mass of 2.5 and velocity of 4.8 in a direction of an angle theta to a line AB. Very good. So here we have the vertical component of the velocity of the ball X and vertical component of the velocity of ball Y. So much. Now notice that the arrow needs to align with the arrow of the velocity, right? So you are not going to draw this arrow up, need to be down because it needs to align with this arrow, the original arrow of the velocity. Likewise, this one. So the angle here we don't have. So and then, but this angle here is the mirror of the other angle, and likewise this one too. So now we can write the expression for the horizontal velocity for the ball X, which is 4 times cosine of theta. The components of velocity, force, displacement, or momentum, they are all in terms of sine and cosine. So let this make it very easy. And the component of the velocity of the ball Y is 4.8 cosine of theta. Now we have here an expression for the momentum after collision. So momentum original formula is mass times velocity. The masses combined, 3 plus 2.5, which is the mass of X and the mass of Y, times the speed they are moving. So now we are going to use this expression of conservation of momentum in one direction, which is the line AB, before and after collision. So now we are going to add, because the sigma means sum. So we are going to add everything is in this direction. So mx vx plus my vy is equal the sum of the masses times the final velocity. So 3 times 4 cosine of theta plus 2.5 times 4.8 cosine of theta is equal to 3 plus 2.5 times 3.7. So this is 12 cosine of theta, 12 cosine of theta, and equal 20.35. So then you have cosine of theta is 20.35 divided by 24. So theta is the inverse of a cosine of this division right here. Plug in your calculator, doom, 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 and you have 32 degrees. Now the last section of this question is asking this. By calculation of kinetic energy, so you need to calculate. State and explain whether the collision of the balls is inelastic or perfectly elastic. So let's start. We need to calculate the initial kinetic energy, which is the kinetic energy of the ball X plus the kinetic energy of the ball Y. The formula for kinetic energy is mass times velocity squared divided by 2. So we are going to add both. Let's do substitutions. So is the mass of X is 3, the velocity of X is 4. And I know what you're thinking. Well, so how come you're not using the X direction or the Y direction? Because energy is not a vector. So we are using the original velocity provided in the question, which is 4. Evaluate the components. So 3 times 4 squared over 2 and 2.5 times 4.8 squared over 2 We add both and we have 52.8 joules. So now let's take a look what happened to the final kinetic energy. For the final kinetic energy, remember both masses are add together because they are going together, times the final velocity square, which is 37.6. As you notice, the initial kinetic energy and the final kinetic energy are not the same. There is a loss of energy, maybe sound, the balls snap, boom, make a sound, a heat, a friction. So there are some loss of energy. So for this reason, the initial and final kinetic energies, I should say that, are not the same. Therefore, the kinetic energy is not conserved. This collision is inelastic. This question is about double slit. Great review. Light from a laser is used to produce an interference pattern on a screen as shown in this picture. The light of wavelength 660 nanometer is incident normally on two slits that have a separation of 0.44 nanometer. The double slit is parallel to a screen. The perpendicular distance between the double slit and the screen is 1.8 meter. The central bright fringe on the screen is formed at point O. The next dark fringe below point O is formed at point P. The next bright fringe and the next dark fringe below point P are formed at points Q and R respectively. The light waves from the two slits are coherent. State what is meant by coherent. So in this picture here I have two waves, a red and a blue. They have the same frequency, they have the same wavelength, therefore they have a constant phase difference. So coherent are waves with the same frequency or wavelength with constant phase difference. For the two light waves superposing at R, calculate the difference in their path lengths in nanometer from the slits, the path difference and the phase difference. Before answering this question, let me look here the picture they provide, the diagram, and I place here a table with path difference and phase difference for each fringe, the central and the alternating ones. So at the central is like a zero order, right? So the path difference is 0, and what's going on here is because both waves that come from these slits, they are arriving here together. So there is no difference. They arrive one over another. So there is no path difference between them. The dark fringe, we have a destructive interference, so which means that the one is behind of the other one, half of a wavelength. And the bright fringe means that we have a constructive interference. So they kind of arrive together, but one is behind one wavelength long. The next one at the dark, again, is destructive interference. So the difference here is 1.5 wavelength. All right, 1.5 wavelength is going to produce a destructive interference as well. This is a wavelength and this is the correspondent angles in degrees. For example, this is the intersection with the wave on the horizontal and vertical line. So here we have 0 degrees. So this corresponds to 1/4 of a wavelength, corresponds to 90 degrees. This is half of a wavelength, corresponds to 180 degrees. This is 1 to 3/4, corresponds to 270, and this is a complete wavelength, 360. So if I add half of a wavelength here, and then that will correspond to 540 degrees. So now we have the complete table here. We may not even need all this information, but just for you understand that the path difference corresponds to the difference in length in terms of wavelength, but the phase difference is in terms of angles. So to calculate the path difference, all that we need to do here is the fringe R corresponds to 3.5 wavelength, which is 3 divided by 2 is 1.5. The wavelength is 660 nanometer, and the result is 990 nanometer. For the phase difference at point R or at R fringe is, again, is 3.5 of one complete wavelength, which is now 360 degrees, and when we multiply everything, we have 540 degrees. Now the next question is asking to calculate the distance OQ. OQ. So it's between two bright fringes. Okay, how we do that? We need to use this formula here, which is for double slit. Wavelength is equal to the distance between both slits times the distance between two consecutive bright fringes or dark fringes. In this case is O and Q, so two consecutive bright fringes, and D is the distance between both screens. So what do we have? We have A, we have the wavelength, and we have D. So doing the substitutions, and well, I like first to rearrange the formula in terms of the variable that I'm looking for, and the distance is 2.7 times 10 to the minus 3. Now the light that comes from the slits has a change. One of the light has a double the intensity and kept the same frequency. So how this will affect what we see on the projection, on the fringes appear. So right here. So number one, fringes, bright fringes are brighter because now one light is more intense, has a higher intensity, greater amplitude than did before. No change to the dark fringes. You cannot make a dark get darker. And according to this expression here for the double slit, and this will not affect any other variable. The distance between both screens are still the same. The distance between those slits are the same, and the distance between two consecutive brights and two consecutive darks is still the same. So the only thing you change is that the bright fringes will be brighter because one light is more intense. The next question. Now the light of 660 nanometer is replaced by a blue light from a laser. State and explain the change, if any, that must be used to the separation of two slits so that the fringe separation on the screen is the same as it was for light wavelength 660 nanometer. So because blue light has a shorter wavelength than red, keeping the same fringing spacing X in a double slit pattern requires reducing the slit separation A. So the wavelength decreases, therefore the distance between two slits also decreases. Question 6. A network of three resistors of resistances R1, R2, and R3 is shown here in this picture. The individual potential differences across the resistors are V1, V2, and V3. The current in the combination of the resistors is I, and the total potential difference across the combination is V. Show that the combined resistance R of the network is given by R is equal R1 plus R2 plus R3. This is a series circuit. All the resistors are connected end to end. So we can use the total potential difference, or total voltage, is equal to the sum to the voltage drop on each resistor. So V is equal to V1 plus V2 plus V3. According to Ohm's law, V is I times R. So we can do all the substitutions here, the all multiplication, I R1, I R2, I R3. The current is common, is the same for all three resistances. So then we have IR is equal to I R1 plus R2 plus R3. Therefore R, when you cancel current from one end of the equation to the other one, II, so R is equal R1 plus R2 plus R3. A battery of electromotive force EMF 8 volts and negligible internal resistance is connected to a thermistor, a switch X, and two fixed resistors. Shown in this picture, R1 has a resistance of 6 kilo ohms and R2 has a resistance of 4 kilo ohms. Switch X is open, and calculate the potential difference across resistor R1. So here is this blue line is showing the where the current is flowing. The current is not flowing through the thermistor because the switch is open. So we just have this circuit here. Now to calculate the potential difference across resistor R1, we can use a potential divider. And the potential divider formula is V out, or output voltage, is equal to the input voltage times the resistor where we want to calculate the V out, or the output voltage, over the sum of all resistors in series. That's the only reason why we can use here, because all these two resistors, or if you had more, they are all in series. So then we do substitutions, and I wrote here K, but K is 1000. We can do either or, and then V out is 4.8 volts. Now the switch S is closed. The resistance of the thermistor is 12 kilo ohms. Calculate the new current now in the battery. So when they say the current in the battery is in series with everything else in this circuit, so is the same current that is flowing here. Now one thing that I did is that this resistor R2 is in parallel with the the thermistor. The thermistor is a resistor, but is a resistor which value changes with the temperature. They didn't mention the temperature here, but that's okay. But we have the value of the resistance of the thermistor. So because they're in parallel, so then I replace this branch right here with this resistor here to make it easier for you to understand what's going on. So the combined resistance here is the 4 kilo ohms for the resistor 2 in parallel with the 12 kilo ohms for the thermistor. So using the inverse, we know that when they are in parallel, we have to add the inverse. So we add the inverse, don't forget to inverse one more time. So then the result, the combined resistance of this parallel combination is 3000 ohms. Now using Ohm's law one more time, but now for current, which is voltage over resistance, we can calculate the current flowing through the battery, which is the same current that is flowing through the entire circuit when the switch is closed. Now, well, with the exception that the current is going to split between the thermistor and the resistor 2. Anyway, the voltage here is 8 and the resistance is the combined resistance again, one more time. Now this time they are in series, so we have to add them. We don't add the inverse. We add the inverse when they are in parallel, and we add the values when they are in series. So now it will be 6 plus 3, which is 9K. So 8 divided by 9K is 8.9 times 10 to the minus 4 amps. So that's the current flowing through the circuit and through the battery. Now the last question from this electricity problem. The switch X in the circuit in B remains closed. The temperature of the thermistor decreases. So right here I have some stuff for you. So if the temperature decreases, then the resistance of the thermistor increases. So they are inversely proportional. By reference of the current in the battery, state and explain the effect, if any, of the decrease in temperature of the power produced by the battery. Right, so in order to determine how the power is going to be affected by this transition of temperature, you have to realize that you need to find the expression that relates the current with the total resistance now. So the current is voltage over resistance. Now the resistance is going to increase because the thermistor temperature decreases. Well, if this happens, and then the total current in the battery is going to decrease. Now the power of the battery, one of the formulas, there are several formulas, but one of the formulas for the power, for the electrical power is voltage times current. So the voltage remains the same, but the current is decreases. So the power decrease, right? So the current decrease, they are directly proportional here, so the power decreases. Last questions about particle physics. A nucleus of cesium-137 decays by emitting a beta minus particle to produce a nucleus of an element X and an antineutrino. The decay is represented by this nuclear equation and state the number represented by each of the following letters, P, Q, R, S. This is a very simple question. So in this nuclear equation, all that we need to do is apply what we know about conservation of mass and conservation of charge. So which means that the sum of the mass on the left side of this equation need to be equal to the sum of the masses on the right side of the equation. In other words, we can say this. 137 needs to be equal because the 0 means equal. The arrow means decay, but we can do equal here to make it easy to understand what I'm saying to you. So Q plus, now this P is a beta particle, so beta minus particle is an electron. So the electron, the mass is 0 and the charge is -1. So P is 0, and this is the antineutrino. Antineutrino is part of the beta minus decay, so it's always there. So there is no mass and no charge. Okay, so 0. So therefore Q is 137. And the bottom one is 55 is equal S. Now this is the electron, so the charge is -1, and this is the antineutrino is 0, so S is 56. So P and R is part of the electron, so P is the mass, is 0, and the Q here is the mass of this element X, which is 137. R is the charge of the electron, which is -1, and S is the atomic number of this chemical X, which is 56. State the name of the class or group of particles that includes the beta minus decay and the antineutrino. So here is the standard model. We have two families, hadrons and leptons, and the hadrons had other families. Let's talk about mesons and baryons. The mesons has two quarks. One is a quark, the other one is an antiquark. The baryons has three quarks, so the protons and neutrons are baryons. And for the leptons, we have the electron, muon, and tau, and we have the neutrino and antineutrino for each type of lepton. Now, which beta minus particle belongs to? Well, beta minus particles is the electron. So electron belongs to the leptons. Boom. A particle Y has a quark composition of D, 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 down, 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 where D represents a down quark. A particle Z has a quark composition of a anti-up and a down quark, and where U, which this line over represents an up antiquark. And show that the charges of particles Y and Z are equal. How we do that? Well, the particle Y is D, 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 down, 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 and the charge of down is -1/3 of the elementary charge, -1/3 of elementary charge, -1/3 of elementary charge, because we have 3 Ds. And then when we add this is -3e/3, which is -e. For the particle Z, we have one antiquark and one down quark. So the up quark is 2/3 of E, but because it's anti, we add the minus here. and D is minus 1e over 3. So, and then we have exactly the same. So we prove that both have the same charge, Y and Z. And now is asking to state and explain which particle is a meson and which particle is a baryon. So the meson is Z because consists of a quark and an antiquark, and the baryon is the Y because consists of 3 quarks. So this is the end of this long test, and I hope you can use to review prior your exam, or if you are working with your AS physics level. Thank you for watching for almost 1 hour. Bye.